Hello everyone. Okay, so today we are going to be looking at simultaneous equations. So today we're just looking at regular old simultaneous equations, and in the next video we're just going to be doing some more harder examples. So this video we're asking ourselves, what on earth is a simultaneous equation? So a simultaneous equation, they are two equations with two unknown variables which are both true at the same time. So the equations must be solved either algebraically or graphically to find the unknown variables. So they look like this, right? X plus 3y equals 5, and then underneath it we'll have another equation. For example, like 2x minus 4y equals 10. So we want to find out which value of x and which value of y satisfy both equations at the same time, because these equations have all different solutions. So for example, x plus 3y equals 5. Well, I could say if x equals 2, if I say x equals 2 and y equals 1, well, that is a solution, right? So x is 2, y is 1. That is a solution for that equation, but that doesn't necessarily mean that's the solution for this equation here. So what simultaneous equations is basically asking us to do is we are finding a solution for x and y that satisfy both equations. So let's look at how to do that. Okay, so we need to be able to solve algebraic equations, simultaneous equations algebraically. So the key thing for for simultaneous equations, so there we go, there's my simultaneous equation there. I have 2x plus 3y equals 7, and 4x minus 2y is equal to 6. So the key thing with simultaneous equations is I am using something called the elimination method, which means I am eliminating one of my variables. So I have to choose, do I want to eliminate or get rid of x, or do I want to eliminate and get rid of y? So this is what we look out for. So in order to eliminate a variable, in order to help us eliminate a variable, the number or coefficient in front of the variable we want to eliminate has to be the same coefficient but opposite signs. So if we see here, I have a plus 3y here, and then here I have a minus 2y. So I have the opposite sign thing going on, but they're not the same number. So I need to get these to be the same number. So how do I do that? Right, well, I'm going to be multiplying the equation, right, both equations by something. So what we do is we find the lowest common denominator of 3 and 2. So, or lowest common multiple, I should say. So the lowest common multiple of 3 and 2 is equal to 6. So what I do is I multiply my top line by what number do I multiply by 3 to get 6? Well, I multiply my top equation by 2, and then I multiply my bottom equation by 3. So this is just equation 1, equation 2. It's always helpful if you label your equations. So when I'm multiplying an entire equation by a number, I'm multiplying every single term by that number. So 2x times 2 is going to give me 4x. 3y times 2 is going to give me 6y. And 7 times 2 is 14. That's my first equation there. Next one, 3. I'm multiplying across by 3. 4x times 3 gives me 12x. Minus 2y times 3 is minus 6y. And then 6 times 3 is 18. And that's equation 2. So now what you do is the next step is we add the two equations together. And you see now when we add them, right, this plus 6y and when I'm adding on this minus 6y, that's gonna go to 0. I'm actually essentially getting rid of y. So let's do that, shall we? So I'm going to add both these equations together. So 4x plus 12x is 16x. Plus 6y minus 6y, well, that gives me 0. 14 plus 18 is a number that is equal to 32. So therefore, I have 16x equals 32. Divide both sides by 16. I get x is equal to 2. And there you go. There is my first solution. So remember I said we're looking for x and for y. I only just found x there. So how do we find y? Well, I take this x equals 2 and I sub it into either equation 1 or equation 2. Whatever one you desire, that is a-okay. So I'm just going to sub it into equation 1 because why not? So I have 2 times 2 plus 3y is equal to 7. 4 plus 3y is equal to 7. Bring the 4 over and subtract this. So that's 3y is equal to 7 minus 4. 3y is equal to 3. Y is equal to 1. When I divide both sides by 3, I get 1. So there you go. There's my solution. X equals 2, y equals 1. And just like every algebra question before, we can always check our answer via substitution, right? So, sub in to verify answer, right? I want to sub in to verify. So, 2 times 2 plus 3 times 1 equals 7. And then underneath here, I have 4 times 2 minus 3 times 1 equals 6. So let's check if both of these hold out. Well, my top equation is going to give me 4 plus 3 equals 7. So therefore, it's going to be 7 equals 7. That is correct. So my solution is valid. The next one here, 4 times 2, that's going to give me 8. Minus 3. Oh, sorry, it's minus 2. Sorry, it's minus 2y here. My apologies. See, I make mistakes as well. Minus 2y. So 8 minus 2 gives me 6. 6 is equal to 6. So therefore, this equation is valid as well. So my solutions are x equals 2 and y equals 1. Right, so let's look at another example here. So this example here is a little bit different, right? So this example here, we want to rearrange, right? Rearrange simultaneous equation. Because if you just look here, right, it looks like a simultaneous equation, but there's just a little bit something off. There's a little something off about it, right? So I have 3x minus 23 is equal to y. And in my second equation, I have 2x plus 3y is equal to 8. So what's the story? What's the story? So I always want all my letters to the left and my numbers to the right. Okay, I want all my letters to the left and my numbers to the right. And I want my letters or my variables to be over one another. So I want to bring this y over here and I want to move the 23 back over to the right hand side. So I have 3x minus y equals 23. Then I have 2x plus 3y is equal to 8. Now that's more like it, and now we can get started. So, as you see here, this now looks like a regular, old simultaneous equation we like to solve. So, let's just have a look here. We want to decide, do we eliminate x or eliminate y? Well, I'm looking here and I see, well, my y's already have opposite signs. Just the coefficient or the number in front of them is different. So I want to make sure they have the same coefficient, opposite signs. The opposite signs are already there, so that's gorgeous. We don't have to worry about multiplying across any minuses. So I'm going to multiply my top line by 3 because I want this to be a minus 3y. So I'm going to have here 9x, because 3x times 3 is 9x. Minus y times 3 is minus 3y. 23 times 3 is 69. Then my bottom line is 2x plus 3y is equal to 8. Add both of my equations. So 9x plus 2x is 11x. Minus 3y plus 3y is 0. 69 plus 8 is equal to 77. So 11x equals 77, x equals 77 divided by 11, x is going to equal to 7. So there you go, x is equal to 7, and now I want to find what y is. So I go up and I sub it into equation 1 or 2. I'm just going to sub it into equation 1. So I have 3 times 7 minus y equals 23. 21 minus y equals 23. Minus y is equal to 23 minus 21. Minus y equals 2. Y equals minus 2. And there's our two solutions there. And now let's just double check my answers. So, I have 2 times 7. Sorry, let's just double check my solutions now. So verify my solutions. I have 3 times 7 minus negative 2 equals 23. That's equation 1. And then equation 2, I have 2 times 7 plus 3 times minus 2 is equal to 8. So let's verify if these are true. So 3 times 7 is 21. Minus negative 2. And minusing a negative number becomes a positive number. That is going to be equal to 23. 23 is equal to 23. So therefore it is valid. Right? 2 times 7 is 14. 3 times minus 2 is minus 6 is equal to 8. 14 minus 6 is equal to 8. 14 minus 6 is 8. 8 is equal to 8. Therefore it is valid. Tick. So my solution is valid there. Right? And that's it for this video. I hope it was some help to you guys. And I'll catch you guys later in the next one. Right? Bye.